or I'm trying to have a list. Okay. And that is how I am trying to make a notation. But remember, I have a limited memory. It's not like I have unlimited memory and I can store everyone's height and everyone's, let's say, age or whatever be the factor. So at one point in time, my memory or मेरा दिमाग, okay, मेरा दिमाग भी full हो जाएगा. So that based on that memory uses, that if I make a list, then how much of my memory I am using to remember the people or the items with respect to their numerical quantifiers. Okay. Now I take the list and then I can easily say, okay, ये पहला बच्चा दूसरे नंबर जाएगा, ये दूसरा बच्चा तीसरे नंबर जाएगा, जो भी हो. I can say that. Now the point is that I can say that because I have this idea of the quantifiers. Now how fast can I do that? And say from having 10 kids in a line to 100 kids in a line to 200 kids to 1000 to 1 million kids. Okay. This idea that how fast I would be able to give orders that this kid will go first or last or whatever. That idea that how fast I can do that would be under this computational complexity. Okay. Now recursion and all this stability would be a very much difficult for you guys to understand right now, but we can try doing that. Okay. Recursion. Okay. Recursion কাকে জিজ্ঞেস করা যায়? Yeah.
দেখে দেখে সবাইকে সর্ট করবে, ওটা তো মানে টাইম কমপ্লেক্সিটি 1 তো ওটা মানে লাইক এল ডট সর্ট যে লিস্ট এটা তাই করে।
Oh, okay. No, like I'm giving out orders. Okay. So before আমি দেখে দেখে করছি মানে কি, I have a list, right? So first I need to fill the memory or fill the list. So I'm going one by one and asking each person, beta तुम्हारा height कितना है? Or what's your age or something, whatever be the quantifier. N time complexity. Okay, but depends. No, it uses I think it uses quicksort if I remember correctly. That's a good question. What's the algorithm that what is the name of this? Python. Yeah. What is the algorithm that Python uses under this list sort? Okay. What is the sorting? I think it is quicksort. Okay. I think it is quicksort. Let's check it. Sorting algorithm that Python uses under list dot sort. Okay. Use an algorithm called, okay, it used time sort. Okay, but this is older version. Time sort is a hybrid, but see this. Okay, see this is amazing. This part, you know, like just a few days ago I was explaining the concept of data abstraction, right? I was explaining it to both Somojit and Niket, but I think Dutika তোমাকে কি আমি data abstraction বলেছিলাম কখনো? Do you know this concept or I can explain again? বলো. Okay, we can go over the concept of data abstraction, but I would like someone here, Niket or Somojit. I think Somojit, try explaining data abstraction. पहले ही ना बोल दिया. Niket, oh, क्या कर रहे हो भाई? By the way, this is streaming. Okay, so try to make a good face. Try explaining data abstraction. Try, it's fine. Even if you fail, it's fine. Don't worry. Can you guys try? Oh, no, okay. See, data abstraction for Dutika and for other two like Niket and Somojit, please listen and try to remember it. Okay, or try to at least feel that the examples are right there in front of your eyes. Data abstraction means when the inner working of a function or a mechanism or maybe a variable or whatever be it, okay, be a function, be it some application, be it some algorithm, whatever be it, some data structure, the inner working, that how everything, each and every element is getting transferred here and there, and all this is abstracted away or is hidden from the end user of the algorithm. Okay, like a good example is this one. So older versions of Python 2.3 to 3.10 used an algorithm called time sort. Okay, so they use the algorithm. There are many algorithms, as I told you, but one by one we will go into that. It used one algorithm, but what was the output of this algorithm? That whatever list you give, the output of the list would be a sorted list, right? It will change in the exact memory location, but that's a different thing. But it will be sorted. Okay, so the idea that मैं इधर से आलू घुसाऊं तो दूसरी तरह से लेट्स से सोना निकल रहा है, बकरी नहीं निकल रहा. Okay, that idea is staying constant, that whatever I am putting inside, I'm going to get the same output. But in from Python 3.11 or 3.11, what happened? Python started using power sort. So which was another, like I think it's Sebastian Wild. Okay, so that guy is a very popular programmer. Even I think in the Linux kernel, somewhere he's very popular. If I may be wrong, I need to check, but he is quite popular. So this algorithm is a new algorithm, but the output change? So I used to give a unsorted list, and now also I'm getting a sorted list. Okay, but the inner algorithm has changed. So Python में जो that list dot sort है, it is abstracting away how the inner working of that algorithm is actually going on. Okay, and that is how your various, like this data abstraction or all this, are being portrayed. Okay, so let me search this programmer or developer.
স্যার বলছি সর্টিংটাকে ডিএস এর আন্ডারে করে বুঝি?
Okay, good question. I would say it is okay. This is the guy, Sebastian. I think
লিঙ্কডইন প্রোফাইলটা খোলো না।
LinkedIn, of course we can. He Orchid ID আছে. Let's go his LinkedIn. Okay. Oh, this is another browser. I have to open and sign up. Okay. Search him later, not now. Okay. We can see his resume somehow. I think this is his page. If it opens up somehow, today my internet is not working that great. No idea why. So let it open in the background. Let's continue. What I was going to say is about data abstraction and all this. Now, we have done through various different classifications. One of them would be recursion. So, Niket, do you remember what recursion is? What is the meaning of recursion?
একটা ফাংশন থাকে।
Is it something where both, like if I call one function, it will call itself again and again, but there should be some condition where it will stop, right? There should be some condition where it will stop, right?
ডিটারমিন্ট ক্রেমার ছিল এক সময়।
Yeah, but you should be remember it. Dutika, do you remember recursion? Kind of. Can you like at least say one line about recursion?
You said
Yeah, bolo.
a function calling its own function again and again
Mhm.
before a criteria is met, like if we can do the Fibonacci sequence like that.
Yes. I think I did the Fibonacci sequence and showed you that example, right? So, what? বল।
একটা ফাংশনের ভিতরে একটা ফাংশন, তা আমি যখন ওই মেইন ফাংশনটাকে যখন কল করছি, তো ও যখন কল করছি ওর ভেতরে যখন এই ফাংশনটা, ওটা তো অটোমেটিক্যালি কল তো অটোমেটিক্যালি হয়েই যাবে।
No, there is like, okay, when you call your, let's say you call your friend, okay, who is with his girlfriend. So you know what's going to happen. He's going to call his girlfriend and both of them will come to you. Okay. Now, how this happens. You call your friend. It's not like immediately her girlfriend will come along with him. Okay. So he has to convey the message to his partner. That kind of, let's say, delay, or when you call something, then it has to call another thing. That means what? It happens in a sequence, right? So this sequence needs to be maintained. And let's say you have a, you call a function, say function 1. Okay. You call a function, say function 1, and then you call another function, say function 2. So what's going to happen? The function will continue, will complete its execution. Then function 2 will start its execution, right? So what is this data structure? Can I get some idea? Nested? No, I'm saying if I have two functions, say function 1 and function 2. Let me just write it down somewhere. Say I'm writing it here. Okay, let me zoom in a bit. Say I have functions. Okay, say function 1. Okay, I call function 1 and then I call function 2. Okay. Oh, sorry. Something happened. So this is the first function that I call. Say this is number 1. This is number 2. Okay. So when I call function 1 and I myself am calling function 2, what's going to happen? First, the function 1 will complete its execution. Then function 2 will come and complete its execution, right? Do you get it? But suppose it happens in some another way, where function 1, I only call function 1, and then function 1 calls function 2. Understand the differences? For in this scenario, I'm calling only one function, which is function 1, and after a while, the function 1 calls function 2. That means I never called function 2, but it was being called upon by function 1. So what's going to happen? Who will first complete its execution? The function 2 will, yes, the function 2 will first complete its execution. Then function 1 will complete the rest of its execution. What is the data structure here? You can imagine. Is it a stack? Is it a queue? Is it a tree? Is it a graph? So Somojit, কি টাইপের data structure বল? Somojit, কি হলো? দাঁড়া ছেলেটা কি হলো? Is he in the meeting or what? Let me see.
I'm এখানে
হ্যাঁ, so what is this type of, হ্যাঁ বল। আচ্ছা,
नहीं आ रहा भैया, याद नहीं आ रहा।
ऑप्शन क्या है तेरे पास? ये मुझे बता। 2 सेकंड रुक जा। सोमजीत, ऑप्शन क्या क्या है तुम्हारे पास? What are your options? What could be your answer? Like, what are your options right now?
Key or graph, नहीं।
ट्री और ग्राफ तो
याद
लग
नहीं
रहा
आ
है, क्या होगा क्या है? Like, does this
याद
like,
नहीं आ रहा भैया।
okay, Niket, try.
Last in first or stack.
Correct. So in one shot, he said the correct answer. This is a stack. Okay. So what is happening? So the first person who went inside the call, that is function 1, then it called function 2. The function 2 got called inside, and then function 2 completed its execution. Then it got out. Then function 1 completed, right? So isn't it like you are putting something inside a stack of books, stack of clothes, or inside a bucket, okay, and you can only take out the last thing that you put in first, right? So whatever you put in the first, which is the function 1, it came out at the last. So philo, जो भी बोलना है, okay. You get it, right?
LIFO.
So I say LIFO. Last LIFO, right? Last in, first out, yeah. So
First out.
first in, last out. That is also correct, right? First में क्या गया? Function one गया. ये last में निकला. So it works. It works. Philo बोलो, LIFO बोलो, it's fine. Okay. Because think about it, your operating system is calling multiple functions, right? If I just say I open my terminal and show you simple my htop, okay, you will see, okay, something is taking too much of my processor. Don't mind that. But see all these. What are these actually? These are all functions, or you can say processes, right? These are not exactly functions. These are processes. So all these processes are running right now. And because all these processes are running, they are not like able to run all at the same time. So the processor, the CPU is switching between all these processes. Okay, so a single core is switching between all these processes, and because there are multiple cores and multiple threads, they can handle parallelism. So parallel processing can happen, but a single core is trying to execute multiple processes concurrently. Okay, means it is shifting from one process to another at a very rapid pace. Okay, so hopefully that is understandable to you. Now, recursion is, yes, of course, recursion is nothing but internally it is running a function, something called function stack. Okay. Ask away. No issues. Bolo.
That first stack, can you explain the other data structures?
Except which one? Except for stack the other data structures. Yeah, I can. Don't worry. Like, let's do that in a very short manner. Okay. Because you will be learning all this in your next, next year. So don't worry. This is a queue. Okay. The other data structure that we were talking about is queue. Okay. So I would like to say these are actually abstract data structures. Okay. Means the inner working is hidden. So in a queue, you will find that people are waiting. And the first person who is there in, let's say, in front of a bakery shop, or I have been using this bakery shop example a lot, like too many times. Say at this point, use this example, ATM. So the first person who got there to withdraw money or to deposit money, that person will be the first who will complete the task, right? So it is first in, first out, or last in, last out. Okay. This is a concept of a data structure. Okay. Now suppose inner working of that data means each and every, say, node, memory node, which is having that data. Say the data is something like 10, 20, 30, 40, 50. So that data needs to be stored in a structure, right? And without ever telling you, I can change the internal structure of how these data are stored. And that internal structures are governed by something like the different data structures, which would be your arrays, linked list, tree, graphs. Okay. Those are something that will work under the hood. But bahar mein, this is like a queue. And there is something like a stack. Okay. And again, there are actually different types of these data structures. There's something else. There is something called trie. Trie is another form of data structure that is used for. No, I never, because I'm just saying names. Okay. So how many of you have used autocorrect in your daily life? So you are right. So the algorithm behind autocorrect is a trie algorithm, or the trie data structure. Okay. So this trie data structure is like a tree, but it is very fast. Okay. Very vast and very fast. The both of it. So you will see that the Google keyboard takes about, I think, what's the size of Google keyboard or any of these like keyboards? It's about in like, I don't remember exactly. I think around 14-15 MB से तो ज़्यादा होगा ही, right? It's like it's more than 14-15 megabytes. I think this try dictionary takes about 12 megabytes or something. Whatever. I forgot the exact size, but all the English words, English dictionary letters, all those things are stored in form of a try data structure so that it can quickly predict what could be the correct spelling. Okay. Do you get it? समझ में आया? हाँ बोलो. Someone was saying something. Okay, so these are different data structures, and these are abstract data structures because the inner working is hidden from us. But things which are not abstract, which would be your stack queue, and there is one more thing which is tree. Okay, so I should have not written just tree. So I should have written tree and graphs. So what are these tree and graphs? These, okay. Before I go into what are trees and graph, let me tell you one more thing, which would be linear data structure and non-linear data structure. I think last day I was having a good enough class on this. If I can open the note from last day, it would be great. Let me see. Data structures, stacks and queue. Yes, if I remember, yeah. Give it a second. So till now, what we have discussed about stack and queue, they are what? They are linear data structures. Okay. Means if I take any node, which are not the terminal nodes, by node I mean any data or any particular person inside that data structure, then there will always be one successor and one predecessor. Okay. But what is a non-linear data structure? A non-linear data structure means that particular idea that there will be only one successor and one predecessor, that idea gets thrown out of the window. So because we are now having more than one predecessor and successor, we create a nonlinear data structure. And understand there are two types of nonlinear data structures. One would be a tree, so basically a acyclic graph. Another is a graph. Okay, so what is the difference? You will see that a child node can only have one parent. Okay, but a parent node can have multiple children. You get it, right? So every one of us only have one father or one mother. Okay, in this particular instance, we are going to consider mother. It's not like we have multiple mothers. Unless and until you are talking of some weird bioengineering miracle where you are being born between two mothers and you took some DNA from this one, whatever. We are not talking about those cases. Okay, we are talking about the most natural cases that can exist. In that scenario, we only have one mother, but we can basically be mothers or fathers of multiple children. So this is a tree data structure. And what is a graph data structure? A graph data structure would be one where imagine you friends. Okay, so if you are having friends, the friends के भी friends होंगे, दोस्तों के भी दोस्त होंगे, दोस्तों के दोस्त के तुमको जो पहचानोगे उनमें से किसी को. So then you just draw a line. So that is an analogy to give you an idea what is a graph. Okay, यहाँ तक चलेगा. Hopefully, Dutika, was I able to make you understand about the different data structures? Okay, chalo. So we can continue. We were going to talk about different stability factors. Okay, we want to talk about stability a lot, but in case of, let's say, sorting algorithm, how can you judge what is a stable algorithm? Okay, when you take, say, when you run that algorithm over multiple instances, you tend to see that the predicted form of, let's say, algorithms moves are being taken or not. Based on that, you can do something which is called a confusion matrix, which I'm not going to get into too much. Better not get into that. Okay, this stability factor,
কি ম্যাট্রিক্স বললে?
confusion matrix. Okay. This is called confusion matrix. It's not like something that will confuse you. It is about true negative, false negative, false positive, true positive. You will learn all of this when you get into a little bit of stats. Okay, not now. Yeah, bolo.
Precision and recall or something like that.
Oh, yeah, correct. Do you know about this? Okay. So basically, precision and recall, and these are actually other not parameters. These are like metrics. Okay. Those metrics are basically defined on true, positive, true, negative, and all this. Okay. You take the ratio of them. Okay. I'm not going to go into that, but you are absolutely correct. It's just that it's the other way around. Recall and precision and F1 score are coming out of different ratios of this true positive, false positive, all this. Okay. So they are coming out of those confusion matrix. Okay. Abhi nahi jate isme. But we can have a discussion on that. Okay. That's a good thing. It's good that you are showing interest. Now let's continue. Comparison sorts. So these are sorting algorithm which tend to compare, means is this one the greater one, is this one small, is this one equal to this, or which one it is. They tend to have this kind of logical operation where it checks for greater than or less than or equal to equality. Okay. Now here is the difference between the comparison sorts. These are all algorithms which uses some form of that logical greater than equal to stuff. Okay. And in this particular sorting algorithm, we will do heap sort, merge sort, probably not heap sort because that will be thoda sa difficult, but yeah, quick sort, cell sort, insertion sort, bubble sort. Okay. Now here I want you to notice a few things in the sense best, average, worst. So do you know what these metrics mean? Do you know what does this metric mean? These are talking about the best time complexity, the average time complexity, and the worst time complexity. So I remember I taught you time complexity. Somojit, please can you try answering what is time complexity? At least answer it in form of an analogy or something. It's fine, but try answering it. Nikhil, do you want to try? What is time complex?
অনুযায়ী মানে কটা আমি ইনপুট দেবো সেটার উপর ডিপেন্ড করবে সেটা অবভিয়াসলি। লাইক মানে ও অফ ওয়ান এন যদি থাকে তাহলে একটা ইনপুটের জন্য ওয়ান টাইম কমপ্লেক্সিটি মানে এটা লিনিয়ারলি বাড়বে।
Correct. So just make your language a little bit more clearer. Suppose I increase my input in form of linearly. Linearly means, of course, my inputs will increase. Okay. Say I from 1 to 2 to 3 to 4 and 5 and 6. Always this is linear. Okay. The x-axis is always 1, 2, 3, 4, 5, 6, 7, 8. Okay. But my point is that if I take those as input to an algorithm, how will the time required to process those many inputs will increase? Say I take 10 inputs, then I take 20, then I take 30, 40, and then 1,000. So will the algorithm take 10 seconds, 20 seconds, 30 seconds, 1,000 seconds? Or will it always take 10 seconds? If it always takes 10 seconds, then that means it is O of 1. Very good. And if it grows linearly with the inputs, then And if it grows quadratically,
of n square.
very good, very good. So that hopefully makes you understand what this parameter about time complexity means, right? Dutika, বোঝা গেছে? Oh, okay, sure. Say you have n inputs, okay. Means, say I have a number 1 and I put it inside an algorithm. That algorithm does something, jadoo karta hai, and it gives an output in 1 second. Then I put 2, it gives an output in 2 seconds. Then I give 3, it gives an output in 3 seconds. Then I give, let's say, 1000, it gives an output in 1000 seconds. So the algorithm is growing or is taking time in a linear fashion as the input grows linear. Okay. So that means the time complexity of that algorithm will be linear, or big O of n. Okay. Here, big O is something like this point. Capital O. Big O of, here it is n log n. So this is just given as a other thing. But now suppose I give 1, then that algorithm is taking 1 second, 2 for 2 seconds, then 3 for, 2 for 4 seconds, then 3 for 9 seconds, then 4 for 16 seconds. So the algorithm is taking time in quadratic, squaring the inputs. Okay. So that would be a quadratic time complexity. Big O of n square. समझ में आया?
Yeah.
আচ্ছা সৌম্যজিৎ
স্যার বলছি
বুঝতে
টাইম
পেরেছিস?
কমপ্লেক্সিটি ডিক্রিজিং ফাংশন হতে পারে?
If you ever find that na, that with your input, with your increase in the number of inputs, that it is going to take actually, actually there is wait a second. If I remember correctly, grep is one of those algorithms where that becomes faster with the input size. If I remember correctly, just a second. Grep algorithm. It is fast because it avoids looking at every input byte. Grep time complexity. Oh, actually, yeah, it's very difficult to give a. It's difficult to give a কি বলে ওটাকে, time complexity for grep. It is not exactly a function. No, it is not exactly an algorithm. That's true. So no, at this point, no. In my sense, that there is no algorithm such that if you increase the input size, the time for computing that will decrease. If there is, that will be world changing. Maybe you can actually try building that kind of algorithm. I don't know. I'm not that good. Okay, let's continue. What do we have? We have merge sort. See, best, average, and worst. First, understand this. So, what is the best case scenario when you try to sort an array? Can you give me the best case scenario? What could be the best case? Niket, can you try? Something like, suppose you want to buy, you went to a shop and you want to buy a Spider-Man t-shirt. Okay. And as soon as you go into the shop, the seller is ready and showing the Spider-Man t-shirt right in front of you, or he was folding it. So that is the best case scenario. You can directly say that you want this t-shirt and you will get it at the fastest manner,
হ্যাঁ,
right?
তাহলে এখানে বেস কেস কি বলতে চাইছো?
Yes, that's my question. What could be the best case scenario for a sorting algorithm? That is my question to you.
ও, ওটাই তুমি জানতে চাইছো? আর সবচেয়ে
হুম।
কম? ও না, এটা কিছু বলতে পারবো না, ভাবতে হবে।
Dutika, can you try?
Is it something like the list has distinct data to sort?
The list will at least always have distinct data. Let's say it always has a distinct data. Then what could be the best case scenario? Very good. Correct. It is already sorted. That means the sorting algorithm need not to do any work. Okay. Yes. So then what is the worst case scenario?
পুরো ডিসঅর্ডারের মানে বিশাল লেভেলে চলে গেছে।
Okay. Not exactly correct. Dutika?
Sorted in the opposite way?
Correct. It is sorted in the opposite way. So understand that even if it is disorder, the disorderedness is still in the middle of a Gaussian spectrum. Okay. Means even in whatever be disorder, there will always be some particular set or subset in that particular array where it will be sorted. Okay. Sorted means in the sense the larger value is further away from the smaller value. Okay. But if it is completely in the opposite order, means I am going to sort in the ascending order, and the array is given to you in the descending order. That means there you have to run the algorithm on all the memory elements again and again at the maximum possible instances. So correct. And what is okay? I'm not going to ask the average. It is a statistical average, and it will be difficult to explain right now. But just take something like an average of the best case and the worst case scenario, which would be something a distorted array. Means not distorted. Sorry, a disordered array. Okay. Fine. Chalega. Now, if we continue and look at the algorithms, you will see that for all these algorithms, at least in the beginning, all of them are the same. Best case, worst case, average case are the same. But as soon as you go to some, let's say, sorting algorithm that is of our concern, say quick sort. Okay. You will find that n, it is the best case is n log n, but the worst case is n square. Okay. And there is something like insertion sort. So where the best case is linear, and the worst case, or in the case of average, it is n square. Bubble sort is also the same, and there is odd even sort is also the same. Selection sort is n square all the way. Cycle sort is also n square. Now notice there is one more parameter, which is memory. So just like big omega, we also have one parameter which is called space complexity and a sigma. Okay, so big sigma. What does space complexity mean? It means that when you are doing the sorting algorithm, are you taking note or are you putting anything inside the memory? So say you want to sort n bytes, and in the memory you created a map of n bytes. Okay, so that if the number of bytes increase, then the memory consumption will increase linearly, and that is an example of linear space complexity. Hopefully you get it right. So in most of the cases, you will see that the memory complexity has been kept at 1, or had been has tried their best to keep it at 1. Okay. Now there is something called non-comparison sorts. What are non-comparison sorts? Means they are not going to employ any of those greater than less than sign. So how do they, if you don't compare between different values, how can you actually sort an array? So they depend on something like a very weird way of saying it, but they don't depend on comparison or the absolute truth, but they do it through a randomness. Okay, they try to basically go against entropy. They try to basically reduce the randomness, okay, of that array. But you are always spending energy by running a computer. Okay. So that's not exception. You are spending energy, right? If you put energy, you can have a negative entropy. But the entropy outside may be increasing. Okay. Not maybe, must be increasing. Okay. So it's a system that matters. The system here is an array. You will find that there are these kind of sorting algorithm which doesn't do comparison. Okay. They count on this randomness, or they count on a very weird way of saying is radix sort is a very like it's a very good algorithm. LSD means least, I think I forgot, least significant digit. LSD is least significant digit, and MSD is most significant digit sorting. Okay. They do this in form of going into the machine code and finding out the mantissa and floating point integers. I forgot how they work, to be very honest. I have to check that. But these are very different than your normal sorting algorithms. Okay. And there are other sorting algorithms which are like, okay, the BOGO sort. Okay. This BOGO sort is a very weird algorithm. Like, if I remember correctly, it would be like waiting for the event when the array will automatically get sorted. Okay. Oh, there is this. I can't believe it can sort. Okay. These are funny algorithms. Okay. And there are actually papers on this. That's the most funniest thing. Like someone wrote a paper. Yeah. Bolo.
স্যার বলছি এখানে একটা পিজিএন হোল শর্ট ছিল,
Yes,
পিজিএন হোল
of
তো
course.
পিএনসি কনসেপ্ট তো।
হ্যাঁ, মানে আমি বললাম না, this pigeonhole is not PNC, it's a concept from probability. Okay. Oh, no, PNC is a concept from PNC. Yeah, sorry. Probability PNC সব জায়গায় চলে. So, you know, pigeonhole principle. Does anyone here not knows pigeonhole principle?
হ্যাঁ, লাইক চারটি যদি পিজিএন থাকে, তিনটে যদি হোল থাকে, পিজিএন হোল প্রিন্সিপাল এটাই বলে যে একটা হোলের মধ্যে একটার বেশি পিজিএন থাকতেই হবে।
Correct. That's correct. That's the pigeonhole principle. Okay. You know, there are weird implications of pigeonhole principle. Like, if I remember correctly, if you are in this world, then you can almost have handshakes with everyone if you know some amount of people. I forgot that. There are weird consequences of pigeonhole principle. Like, you will get to understand weird results that come out of it. But yeah, that's there. Now, we have just gone through a little bit of understanding of all the sorting algorithms, but let's go and see how each and every sorting algorithm actually works. Okay. I think today we shall probably be just understanding the algorithms behind it. And next day we shall be programming or each and every algorithm. Let's see. Okay. The first one which we will be doing is bubble sort. Okay. Let me get the algorithm, not this pictures. I want to just want to have the algorithm right now. Let's see if I think Wikipedia will always have him. Yes, this is the pseudocode. This is what I was looking for. Pseudocode means this is how your programming logic would be written. So it's not exactly a program. You will never have any compiler that will be able to execute this. This is just written in pure English for you to understand. Okay.
অ্যালগরিদম তো এটাকেই তো অ্যালগরিদম বলে।
This is algorithm. Pseudocode is nothing but algorithm.
অ্যালগরিদম তোকে স্টেপ 1 স্টেপ 2 করে সেন্টেন্স ফর্মে লিখে দেবো।
হ্যাঁ, মানে এটা এরকম করেও লেখা যায়, ওরকম করেও লেখা যায়। হ্যাঁ, there are different methods of writing. Okay, so let's see what it's written. So first you have a bubble sort function. Okay, and inside that function you give the list of sortable items, means the list where you will be doing the sorting. So first you take the length. Okay, and n is the length of the array. Okay, and then you make a loop. Okay, and inside that loop you have a variable which you call as swap or a flag. Okay, you keep a flag. So have you swapped between two items or not? Bubble sort is like, you can imagine that in an array a bubble is there which is basically taking up two items at once. Okay, let me see if I have bubble sort GIF. Think I should be having something. Yes, this is a GIF. Is it playing? Okay. Is it playing? Is the GIF playing? I don't know.
Play na static আছে
Static, yeah. Okay, but whatever. Let it be static. But I'm going to show that this is an array and this is like a bubble. Okay, in this bubble, imagine that there is a bubble. Okay. And inside that bubble, only two people can go in. So it goes into this first two people, then it goes into the next two people, and then it goes to the next two people, and it goes on. Okay. So the point is that when you have a bubble, there are two people inside or two data items inside, right? Because there are two data items inside, you can do a comparison. The comparison would be, is the second item larger than the first item? Or is the second item smaller than the first item? Okay. Say here in this case, what do we have? The second item is smaller than the first item and we want to sort it in ascending order. And in ascending order, we know that the smaller item must be at the first one or the must be at the left hand side, right? This is understandable. So this is not the case in a very small array. The small array being this bubble inside that bubble. So what do? You swap it. Okay. Then after swapping, you are satisfied. Abhi to theek hai. Then you go to the next this bubble. And in that bubble, you compare between 3 and 1. Okay. And you basically can't, sorry, I think after this is not the one. This is, sorry, yeah, it is going like this. So 3 and 2, then 3 and 8. So is this sorted? Yeah, 3 is smaller than 8. So it's fine. Then you go to the next one. Then you find, oh, 8 and 1. 1 is smaller than 8. So 1 should be on the left hand side. So you swap it. Then you go here. Then you see 8 and 5. So do you need to do swapping? Yes, because 5 is smaller than 8. So you do swapping again. Then you do this. Then you run the algorithm again. Round 2 you do it, round 3 you do it, and round 4. Round 4 you will see that here in that bubble you never needed to swap any of the variables. Means if you kept a variable which will count or which will take note that have you ever did the swapping action once or not. Okay. If you ever did or if you ever what do you call this? Did or applied the swapping function, then that counter will keep a note of that. But in a sorted array, do you really need to do the swapping action ever? The answer is no. In a sorted array, you never need to do a swapping action. So that's how you will know that if a array has been sorted or not. Okay. So how do you do that? You keep a flag that have I swapped this particular section in this particular run. Repeat is while loop. You can do it with for loop. It's up to you. It's whatever you want to do. Fine. Whatever loop you want to use, it's up to you. Next, for I. Okay. By the way, Dutika, are you there? Yeah. So you know what's going to be coming to all of you as a homework. Basically implement this bubble sort array, right? For Niket and Somojit. Somojit, are you there still in the meeting? Haven't heard from you in a while. Bro is like, yes, sir. But my point is that why are you not talking? What happened to your microphone? Okay, let him write. So the homework for everyone here would be to implement bubble sort in Python. But for Dutika, your homework would be not only to implement it in Python, but also in C. So you got that, right? Because currently you know both Python and C, so you will be doing that. Okay.
Okay.
ओके, ज्यादा जानने का यही प्रॉब्लम होता है। ठीक है, चलो। ओके, सोमजित बोल रहा है माय माइक इज नॉट वर्किंग प्रॉपर्ली। ओके, इट्स फाइन ब्रदर, डोंट वरी। So, Somaji, just can you tell me, will you be doing the homework and when you will be showcasing it? Oh, guys, everyone, write the algorithm, and after you do that, put it on your GitHub or put it wherever you want, but show me the program, okay? And I know bubble sort is a very, very simple thing. I just have this one request. Please do not use ChatGPT, Gemini, Claude, whatever. Please just do not use any of the AIs. Just do the algorithm, write the code by yourself, maybe even on a piece of paper. Don't even like use a compiler, just write it on a paper, okay? But do it. Now let's continue.
প্রোগ্রামটা কি তার উপর তো অ্যাপ্লাই করে বাবল শট?
Bubble sort. Yeah, inside your head. Bubble sort, bhai, bubble sort algorithm. Implement the bubble sort algorithm. That's it. This is not a program, right? This is a pseudocode. Yeah, fine. Just do it, nah. Write it. That's what I'm saying. Yeah. So for the initial value to the length n-1, so this n-1 and all this is basically done so that if it is n, you are taking in the bubble. So last element means it has to be in pair. Okay. It can't be like एक बंदा अंदर है और एक जो है भूत है. Okay, it can't be like a ghost. So it has to be someone. So that's why it's n-1. Okay. So this is basically inclusive, so that all of the elements in the array are included. Okay. So if it had started with I equal to 0, maybe have n-2, and that's how it is. Okay. If this pair is out of order, this is the condition check. So basically you will check that if the I-1, that means the one who is at the 0th index, is greater than I at the next current index. Okay. So that means what? It is checking if the previous term is greater than the current term. So is 3 greater than 2? And the answer is yes. So if it is true, then what we need to do? We need to swap those two variables. So basically 3 and 2 will exchange their position. And as soon as you implement that swapping function once, you have to change the swap variable from false to true. समझ में आया? कोई दिक्कत? Is that understandable? चलेगा? Okay. And then you basically close all the loops. This is your bubble sort algorithm. Okay. Now, this is like optimizing the bubble sort. Okay, by observing that the nth pass finds the nth largest element and puts it in the final place. So the inner loop can avoid looking at the last n-1 items when running for the nth time. So what does it mean? Don't worry. See, after you swap the first two variables, okay, what is happening? If you do the first two variables, you know that you are pretty sure that you swapped it. So every time you don't need to check this part, right? You can directly check this too. But in the bubble sort algorithm, when you complete one round, you always go and check, keep on checking this. Okay. You keep on checking all of this. That check needs to be, there are redundant checks. So the redundant checks you can avoid. That's what it is just mentioning it. Okay. Fine. Can avoid looking at the n-1 when running for the nth. You can go through the algorithm. Do you want, I think you can actually try. So make the homework like this. Okay. All of you guys will be implementing the bubble sort algorithm. Not only the simple bubble sort algorithm, which is the very simple case, but also the optimized bubble sort algorithm as well. ठीक है? चलेगा? कर पाओगे? You will find the differences only for this extra line. And the algorithm has been given to you. So try implementing this in your own language, whatever be suitable for you. This is the homework. Now next, what we are going to do is bubble sort is done. Next, let's do the merge sort or quick sort. Wait, let's do the quick sort and merge sort. कौन सा वाला करें? Oh, linear sort. Yeah, we need to do the linear sort as well. This is a good one. Okay. Do you know? Okay, I don't know how many of you know this about this website. So XKCD. Okay, so this is a very popular website. I'm sending it to you. Okay, whoever linked this to Wikipedia is literally a genius. Not genius, I would say a goated person, whoever did it. So just one second. Yes, correct. Let me. Where is it? Oh, I think I should make a group with all of you together. It's fine. I just send this separately. Okay, done. This particular website is about different jokes. It's a community. Okay, you can actually go and scroll through this website. It's a very funny website. Okay, so see what is this? Linear sort function, linear sort list, start time, merge sort list, sleep 10 to the power 6 time all this and return. Okay, it is a joke. Okay, it's a joke. I don't know how many of you will get these jokes, but yeah, maybe it's Jantavan. I don't know who actually connected this to there. Who did it? Okay, whatever. Let's do the linear sort. হ্যাঁ মানে আমি দেখে একটু অবাক হয়ে গেলাম জেনারেলি এরকম টাইপের করে না বাট ইট ওয়াজ ফানি ইয়েস মানে বেসিক্যালি it's a very মানে Wikipedia is not something that where you will do this kind of jokes, so that's why I was where is the sorting page? This is a radix sort. Okay. Oh wait, let me see. Whatever. আচ্ছা আমি তো আগে একটা জিনিস দেখাই so this is the bubble sort. Okay, just see the bubble sort in action. Okay, see the bubble sort in action. First it will compare, it compares between two. Okay, it always compares between the two values and it is doing that. See, this is the bubble sort algorithm right there in front of just one second. Why is there such features and having noise suppressor? So now the this what they call it array has been completely sorted, and this was done using the bubble sort. Okay, I can't find a linear sort. Just give me a second. I think linear sort and insertion sort are the same, if I remember. Like I don't exactly remember the names, to be very honest. Insertion sort.
বলছি আইজাক ওর কাছ থেকে কি পেয়েছে নোবেল প্রাইজ? Can you see that?
Okay, I forgot this then. So insertion, I think we can go into the insertion sort. So yeah, well, so no, it's not like our ISA Kolkata people got any Nobel Prize. It's that our professor, huh? No. So basically, he was the postdoc supervisor of one of our professors. Okay, Rahul Banerjee. So that's why. So understand that it's like a generation. So Rahul Banerjee was a student of now Rahul Banerjee is a student of a Nobel laureate, and we are student of him. Okay, so it's like one after generation stuff. Okay, it goes like that. And bhai Rahul Banerjee, I somehow cracked his viva. I'm just happy for that. Okay, one of the most difficult vivas I ever faced in life would be the viva taken by Rahul Banerjee. Okay, and it was a chemistry viva, and it was very interesting. But he was basically testing out how much I can actually deduce about the color from just understanding different spectral phenomena and the molecular orbitals. Okay, and he was like, at the end of the day, your answer is good, but you missed this. Then he corrected me where I was wrong. Okay, so yeah, but that was one of the tensed fibers I ever faced in life. So understand that he is a very strict professor. Right? Now let's continue. We have, I think we can go for the insertion sort at this point. Insertion sort. Yeah, this would be then. Good. Yes. Good diagram. See this, how it works actually. You have this whole array, right? Then what do? You first, again, it's like bubble sort because you are taking like elements in like in the form of a bubble, but you are taking it like this. You first check the two items. So is the second item less than the first item? If it is true, then you will push the second item to the first. मतलब उसको धक्का मार के जो है पहले खिसका दो, ठीक है? बट कब तक खिसकाओगे? ऐसा नहीं कि हर एक आइटम जब कम दिखा तो फिर उसको जो है धक्का मार के पहले खिसका दे, नहीं. You will put it in the first after you know that the first part has been sorted. So you will see that it will go like this. 3, 2, it will go before 4. 2 will go before 3. Then it is okay. Then it is okay. Then it is not okay. 1 will go there at the first. But because it keeps a tag of the first item as well. So it keeps a tag of the first item and the last item. It will see that, oh, wait, 1, you can put it in the first, but 5, you put it in the first, it won't work. So you need to put 5 at the last position, which is greater than 5. Do you get it? It will put 5 at the position where the last element is less than 5, or the next to that last element is greater than 5. Okay. And this will continue. Let me show you the algorithm first. Like this. Give me 1 second if I can find it real quick. Intro. Okay. Let me just search it. Is this intro sort? Is insertion sort? Introspective sort. Okay. Maybe insertion sort. This is, yeah, this is the insertion sort. See this? This is how it works. It always tries to kick this guy right in the front. Okay. So let's go and see the algorithm. Oh, okay. See this? How it is sorting?
Like a bubble sort of thing or a fast.
I think it is n log n, right? or n square? No, it is n square. Oh, it is exactly same as bubble sort. Okay, so it's fine. So oh, animation, I showed you a different animation. I was showing you animation from this one. So I will go to the animation. Just give me some time before we need to explore the pseudocode as well. Okay, how the pseudocode works. So let's see pseudocode of the complete algorithm follows where arrays are zero based. Arrays are zero based means the starting element would be zero. Okay. So first you put I as one. Then you check that you have a loop where while I is less than the length of the array. Then you basically take the value of I into j, and what this I and j means, they are the indexes or indices of the array. So while j is greater than 0, and here you check that the j minus 1 means if you are at one position, you will check the zeroth element. Is the zeroth element greater than the first element, or is the first element greater than the second element? If that is the case, then you will swap the two positions. Then you will put j minus 1 means the element which is basically जो पहले वाला इंडेक्स है यहाँ पे जो j minus 1 में था, you will put the index of j minus 1 into j and basically run the loop again. Do you get it? And you will do this again and again from the beginning. Okay. Let's see the animation to understand this. So see this. First, then it takes the second one. Okay, first and then it takes the second one and checks it. Okay. Then 4 and 3, it checked it. Then it is checking with respect to every other element, j minus 1. Then 5, it is checking with 4. Then 6, it is, oh no, 6, I think, oh sorry, it is 9, sorry. 9, it is checking with each and every element. 12, it will go till 12, yes. Then 31, it is checking with every element. It will go check with 41 and 28. जहाँ पे fail करेगा, it will just put it there. 26, it will go and check till 26. And because it fails in 26, it will put it right up to 26. 43, it will just do it.
So
Oh, no, because it is, see the algorithm, it is not greater than or equal to, it is greater than. Okay, so that's why it failed. It failed there. Let me show you again. See the animation again. So 1, it checked with 0. So, sorry, 28, it checked with the previous one. Then 41, it is checking with the previous one. वहाँ पे ही fail कर गया. 24, it is checking with the previous one. Passed, 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 failed. It will put it there. 48, it will check with 41. It failed at that position. 9, it will fail all the way till 0. So is the algorithm understandable to you guys? Somojit, do you have any doubts? बंदा जो है बहुत शांत बैठा है. No, okay, fine. Dutika, do you have any doubts? Niket?
No.
Okay. So hopefully we are done with insertion sort. Now you know what is coming at you guys, right? Basically,
survey.
yes, not algorithm. You need to write the program behind this sorting algorithm. Okay. Got it? Next,
Can I do it just Python?
no, if you want to do it in one language, then you have to do it in C, but you won't be doing it in Python. That's a restriction for Dutika. Are you okay? No, we both here. Okay, fine. Next sorting algorithm we are going to do is selection
একই বলো,
sort.
তোমাকে বলো লিফ শর্ট, এল ডট শর্ট, ওর টাইম কমপ্লেক্সিটি কি তোমার বাবল শর্ট আর ইনসার্শন শর্ট থেকে বেশি না কম?
কিসে?
এল ডট শর্টের যে টাইম কমপ্লেক্সিটি ওটা কি এদের থেকে
হ্যাঁ।
বেশি?
Oh, in the beginning of the class I told you, na, L dot sort
হ্যাঁ
was,
হ্যাঁ। ও
I
বলা
think,
যাবে না, এল ডট শর্ট মানে
no, বলা যাবে।
ফাংশনালি
It
বাইরে।
no, it was power sort. It was using power sort, if I remember. Power
না
sort,
কিন্তু টাইম
wait.
কমপ্লেক্সিটি তুমি বলতে পারবে না, ঠিকই বলছি, হ্যাঁ।
না, power sort বলা যায়। উফ, দাঁড়া, power sort time complexity. So this is the algorithm that is being used in the worst case, and this complexity is also maintained in the average case. And the algorithm is designed to be near optimal with a proven upper bound of NH comparison, where H is the run length entropy of the
এখানে
input
আবার
data.
এখানে আবার এনট্রপি ঢুকে যাচ্ছে কেন?
Remember I told you about stability. There is a reason I was not going to get into that. That's because of this.
ঠিক আছে।
Hmm. No, let me see. What is the time complexity exactly? So, if I can find it. Oh, Sebastian. This guy is a legendary guy, if I remember correctly. Lots of prizes. This is his blog. Okay, I think this is his page. No, this is not his page. This, yeah. Professor of Theoretical Computer Science, Heaps of Algorithm Group, and Department of Maths and Computer, University of Marburg. Okay, Marburg, if I.
সায়েন্স পড়া তারাই কি ম্যাথস পড়ায়? এটা আমি দেখেছি, আমাদের স্কুলের একজন পড়ান, উনি কম্পিউটার সায়েন্স পড়ান কিন্তু ফ্রি পিরিয়ড পেলে ম্যাথস পড়ায়, কি গো?
Because every computer science student needs to be good enough in mathematics. Okay. If you are not
মানে
good in mathematics, or if you can't basically write mathematics properly, then your chances of getting into theoretical computer science is almost zero. Because computer science is at the base is nothing but mathematics. Okay. Hopefully I can make that clear. Next we have selection sort. Okay. Do we have any animation? Oh yeah, see this. Can you understand what is happening? Like just from this animation. Do you get it? What was happening? So you basically pass two agents and one memory agent. Okay. Not agent. I am calling it as agent because I have been working with agents. See. Animation is running. See this. Like from this animation, can you deduce the algorithm? Just from this animation, can you deduce the algorithm? And if I just show this picture to you, can you, from this picture, reverse engineer the algorithm and write it in Python? Or is that too much? Yeah, so let me share you one story actually. So when I was in class 11, okay, so this was Joy sir. So he showed us an algorithm that was working. He just showed us the working. Then he told us to write it. Write it in C. Okay. And we were like, kaise? Okay. So he you know what he did? Basically, the animation that you are seeing, he wrote each and every step where how one thing is happening with in form of drawing. Okay. So, and we were like, we can't understand anything. What was happening? And let me tell you which algorithm he wrote. He wrote the merge sort algorithm. Okay, not this one. Basically, you split the array, you basically split it again and again, and then you recombine it. Okay. I will show you the algorithm, but that exercise, I remember, I wasn't able to complete in class. Okay. Because I couldn't understand how do you even split and then store and then compare. I was only able to write the comparison because that was clear. Comparison कहाँ पे क्या हो रहा है, क्या swap हो रहा है, that was clear. But how do you basically after splitting, how do you store and everything? It was hellishly difficult for. Okay, and there was only one person who could complete that question that was given to us by our sir, by our teacher, and he was Mriganko. Okay, and he is a computer science genius. To be very honest, I can never even imagine reaching his level at this point, and he might be even way better right now than I am. So just I suddenly remembered this story that what used to be given to us at our school level. Now imagine what is given to you guys at your school level. I don't know if it is still that level, then it's good. But if it has deteriorated, then you are missing a lot in your schools. Okay. Now, let's continue. I was just saying you a story. Now, this is the implementation. What you are saying is correct. It goes through. There are actually three elements you will see, and in these three elements, it's going to keep a track, and it's going to pass the other two elements through the whole array. How it's doing it? See this. So I think this is the code direct. The code in C is given. Okay, it's fine, which is good actually. Dudika, please do not copy this. You will be writing it on your own. Okay, I'm just taking this algorithm right of the cell. You have I and j, which are indices. Then you have the array length. Then of course you need to run the algorithm for all the elements in the array. Okay. Then what do? You put a minimum as I. You consider the first element that you encounter to be the least element. Okay, means that value is the least. You assume that the minimum is the first element. Then you test your hypothesis, that is it always the case. Then you run through the array using the j index. Okay, so you run through the array using a j index, but the initial point you change it to the next one. After this, you will see that it is running after the first element 0. It is basically running the searches from the next element, that is 1. Okay, so it is running the search from 1. Then it checks if the element is less than, then it is the minimum. So it checks with hopefully the minimum element. So it checks that the 0th element, which it considered to be the minimum, is that hypothesis stand true or not. So if it is not true, then you found out the new minimum element. So basically you put the index. How do you put the index? You must basically just copy the index of j into the j minimum. Okay. And then you basically run this loop over the whole array. And when do you swap? You only swap when you have one memory here and then two picks, I and j. You only swap when the minimum element is not equal to I. Okay, because you just now transferred j into j minimum. And when you do it, you are only going to swap the variables between the I and the j minimum. If nothing makes sense, just hope you understand that I can show you an animation which will be way easier to get your wrap your heads around. See this. 0, it considers 0 as the minimum element. Okay, okay, I think I can. See, it considers 0 as the minimum element. Okay. Then what it did? It moved on to the next element. Then that was taken as the I. Then there is J. Okay. Then it is going to start the loop again. So if the element is less than the current minimum, 3 is 44. Is it less than the current minimum, which is 8? The answer is clearly no. Then we will go till 8. Is 8 is less than the current minimum, which is 8? The answer is no. But then if we go to 6, जहाँ पे 6th index, the value is 4. So 4 is clearly less than 8. So then what we are going to do? The answer is true. Then we will swap the, okay. Oh, sorry. We are not going to swap, but we are going to change our memory. So now in the memory, we have the minimum element as 4, and which is located at the index 6. Now basically we will run the loop, and this is done. The first run is done. Now we are going to swap the minimum value with the first unsorted position. See this. Is this understandable? समझ में आया? Then after you swap, then you basically again run the algorithm. Now the J minimum is 0. 0th index, you have the most मतलब सबसे छोटा element. So now you will basically neglect it. You have found out the least element in the array. Then what you do? Then you run the algorithm again and try to find the next least element in the array, which would be 8. Okay. And after you found out that 8 is the least element, you basically put it out, kick out of the array, and now you only consider the other remaining values of the array. Then you try to find the least element again. Then again here it is 8. So then you basically repeat the algorithm and always try to find the least element. Here in this case it will be 14. And then again you try to find the least element. Here in this case it would be 21. So now this is how the algorithm moves. Okay. Understandable? Selection sort. कोई डिफिकल्टी, कुछ परेशानी है जीवन में? Guys, any problem? Hello. Okay. Now the point is, I want to just keep it there. Oh, okay. So Majid is saying that no, sir. Okay, very good. Hopefully no one is having any problem. Now, this particular notebook will have all the algorithms that I was basically saying, but I want to share this notebook only after you guys submit the homework on sorting. Okay. Fine. Understandable? দুতিকা করা যাবে তো? Okay. By the way, for you, remember Dutika, you need to do it, all the algorithms in pure C programming language, not in Python. Okay. Only after you complete the homework in C programming language, you will start writing the code in Python. Okay. Niket, you can actually try this if you still remember some of the C and C++ I taught you. But if you don't, it's
তো আমার মনে হয় সব মনে থাকবে কোন ক্লাস 8 এর পড়েছি।
For Somojit and Niket, do it in Python. Okay. Next sort we can do is, should we do merge sort? Merge sort will take some time, but I think we can. Is this counting sort and radix sort? We can do merge sort right now. Let's do it. Oh, this is here, see this merge sort. Okay. This is a very beautiful animation of sorting. Yeah. Wait, let me show you the animation of merge sort, then I'm going to show you the algorithm. Okay. You will see the divide and conquer, how it splits the array again and again. Let's go. So that so the thing. So here it splits the array. Okay. It's splitting the array again and again and again. Then it is trying to try swapping it. Then it is again splitting. Then it is swapping. Then it is splitting again to the right hand side. Well, there was left hand side and right hand. This is not actually that great of an animation to understand merge sort, to be very honest. Let me give you better animation just a second. Yeah, I think this is better. See, this is the array and it's split in the between. Okay. Oh, by the way, how do you split in the between? You just take the middle value. Middle value means the middle index of the array. And then you keep on splitting it. Okay. Okay, this was not a complete. Yeah, split in half, then you merge it. Split in half, then you merge it. Then split and merge. Okay, this is how you do the merge sort algorithm. Wanted to have better animation. Let's see. Can we have some?
Yeah.
Yeah, actually I can make an animation. But it will take me some time. I should have made it beforehand. Okay, we'll share some animation later. See this one. Is this understandable? I think this is the same as this one. Okay, it is still running this animation. Okay, let me go at the say that what is happening. So first you have the array. How many elements are there? 9, right? Sorry, 10. So if you split it in half, what is going to happen? You're going to have sorry, what is the length? I think it's split. Yeah, it's fine. So you're splitting, you will split it in half. Okay, you understand this? Half ले लिया, split कर दिया. Then you are going. Oh, don't worry. It will basically round it off to the nearest index. So if it is odd number, then say 9, then if the length is 9, then it will be 4.5, which basically means 4. Then it will split at the fourth index. Okay. Fine. After you split it in half, you are going to again repeat this algorithm. See? This is now what? This is an odd, na? This is what? 5. 5 को half करोगे तो क्या होगा? 2.5 means you will basically split at the मतलब 3 and 2. See this? Can you understand?
It's 3 and 2 है.
Okay. Now after you split in half, you also again have a odd. Okay, so you will split at 1.5 means 2 and 1. 2 and 1. Okay, well, I'm talking about the length. After you split in 2 and 1, you basically now do the sorting. Means you check that is 0 and 1 कौन ज़्यादा बड़ा है, कौन से इंडेक्स में क्या वैल्यू है. तो यहाँ पे देखो, you basically sort it, means like this. Okay. Do you get it? So this swapping that is happening. Okay. Got it? Then it basically, acha, by the way, this swapping can happen in a very clever manner, which would be doing the summation and okay. There is another homework that I want to give to you guys. Let it run, just which would be, can you swap the value of any two variables without using any swap function, memory function, just use plus and minus. Okay. Do you get my point? Can you swap the value between two numbers using plus and minus, addition and summation? Addition and subtraction. Okay, that's your homework. No loop. Okay, no loop, no temporary variable, nothing. Yes, correct. Okay, see this after you basically sort this. Yeah. No temporary variable. No temporary variable. Only A and B.
এবারে
Okay.
ভেরিয়েবল মানে কি আমার ভেরিয়েবল ভেরিয়েবল
See. Means A and B are the only two variables you will have. Okay. So see after you basically split it and then you swap it. After you swap it, you now have it in order. Then you again do the algorithm. Okay. And you basically do the swapping if required. Then the left path is done. Then you do it in the right path. Then you again do this. Okay. ये देख लो स्वैपिंग हो गया अब ये राइट पार्ट में जाओ okay why is it that I am not able to grab this why is it that I am not able to grab it okay now this is how you will basically swap the right path and then you will take all the things together in the array then you will basically swap it among the array components itself. Can you understand this part? If it is not understandable, यहाँ तक तो ठीक है. उसके बाद देखो right part 3 and 4. So is it in the correct order? It is in the correct order. Okay, very good. Then you will take the whole array and then you will check that is it in the correct order. Means you will check if 24 and 32 which one is less. Means you will check the first index of the right hand side array sub array and the first index of the left hand side sub array. And then you will check which one is less. Okay. And after you do that, you naturally will have a sorted array on the left hand side. But now you need to repeat all the cases on the right hand side. After you are done with the right hand side, okay, then you need to basically combine all of this together. Done. And then you basically copy all the elements back to the original array. Okay.
স্যার বলছি তুমি যে হোমওয়ার্কটা দিয়ে প্লাস মাইনাস ছাড়া কি ইকুয়াল টু ইউজ করা যাবে
Of course, equal to is there. Equal to is means assignment and equality. That is free. But only plus and minus and equal to. Okay. Next, we have merge sort implementation. There are two merge sort implementation. One is a top-down merge sort, and there is this bottom-up implementation. Okay. So I think we can go into this, but it will take us some time. But so I would like to rather have merge sort not given as a homework right now. We will continue the next day from merge sort. Before that, do we have any questions, queries from today's class? This is the end. कुछ दिक्कत कुछ है तो बोल सकते हो. Niket, Dutika, Somajit. Sure, free to ask.
Is the merge sort can be used to solve a cube?
Used to solve a cube, Rubik's cube.
Yeah.
Very good question. And the answer is yes. Okay. But not exactly the sorting that you saw. It was for 1D array. So there are all these sorting algorithms can be applied on multidimensional array. Okay. So answer is yes, and it can be used. Okay. Do you want to take up the challenge of using merge sort on a multidimensional array, say a 3D array? Do you want to take that? It's a good problem. हाँ बोलो. Not now. Okay, fine. Okay, guys. How are your exams? When are your exams starting or something? I think we can stop the stream because the class is over. So I'm